Well, we're turning points where there's a lot of old stuff like Google search that are being revisited and can be done much more efficiently. Search is going to be powered by RAG LLMs. It's the end of PageRank.
Hi, Vincent. Welcome to the show.
Hi, Richie. Thank you very much for the invitation, and very happy to share what I've been doing with my LLM technology.
Wonderful. So I'd like to know why you might want to use a custom LLM when there are so many sort of standard LLMs out there.
Yeah, that's a good question. Initially, when I started to design my own technology, the origins is I was looking for answers using Google search, openAI, GPT, search boxes on various websites, company websites like Wikipedia or Wolfram Alpha. And I noticed that a lot of the results that I was getting were targeted to non-expert, to what I would call the common man. So it would be difficult to find specialized references or focus on topics that are more technical. It really required either multiple prompts if using a tool like GPT or quite some time by using all the search tools, Google or Bing or these search engines. So that was what started the idea of creating a LLM from scratch. Then the other part was that most of these tools, they use neural networks. The training can be difficult, it takes time, lots of GPU. I've read also that they're using billions of weights or tokens that needs to be optimized during the training in particular. There can be latency issues. And I was wondering if it's possible to design something that went much faster and that potentially could offer better results. And by better, I'm not saying here that my LLM is better compared to everything else. It's better in specific contexts. Like, for instance, professional, busy users who want concise, precise, advanced answers to their prompts. So that's what I've focused on. Initially, actually, I crawled Wolfram corpus. So Wolfram is probably one of the best websites that covers all mathematics you can find on the internet. And so even without a neural network, actually. And I was surprised I was getting answers to my question that were, to me, much more useful than I would get from any other sources, even from the Wolfram search box on its website, or even if I do a Google search and I ask Google, I'm looking for results only on Wolfram, I got much better results from what I've been doing. Over time, I got a few Fortune 100 customers that were interested in what I was doing. And then it became more and more clear about the benefits of my rather simple architecture. So just to put some context, initially, I focused on a specialized, simple LLM that would focus on one top category, which was, in that case, statistics and probability, was just focused on that, which is one of the 15 top categories on the Wolfram website. The Wolfram website covers all the mathematics, some computer sciences as well. It's not that comprehensive on statistics, need to be augmented, but that's something we can talk about later. So it started with one I would call sub-LLM. And then, for instance, the Wolfram website, like I said, there's 15 categories. Calculus is another one. Number theory is another one. So you could create 15 different sub-LLMs, then have a system on top of it that managed all the LLMs. So one of my clients actually invented, coined the word LLM router to manage those LLM. You might have heard words like mixture of experts, multi-agent systems that are related to this idea of managing these different LLMs. Also, what I wanted to do is not just return a very wordy, long English sentences to the user, but concise bullet points, different sections. One section would be URLs, links or references. Another section would be related concepts. Another section could be synonyms or definitions, stuff like that. And for each of them, offering the user a relevancy score for each of the items being returned, so that by allowing the user to play with some of the parameters, it could see, how it impacts the relevancy score, what's the order in which things are returned, up to the point that two different users could, with the same prompt, could get two different results if they use different sets of hyperparameters. But to get back to these clients, ABI actually is one of them. So InBev, brewery company in Brazil, which is a very big company. Some of the concerns were, we want local implementation. We are concerned about security, data leakage, and stuff like that. So that was an important thing for them. Another thing was latency. Then, although the issue was, if there is some hallucinations or stuff like that, or poor results or wrong answers, it can be a liability for them. It could end up in being sued or stuff like that. If decisions are made on wrong answers, it's a liability. And the ease of implementation, because there's no neural network, when you test it, it's much faster to enhance the system, to test new features and stuff like that. That's something they were also interested in. We mentioned other things, but that's what the main arguments that I remember. What's interesting also is, so I've been improving and developing these, I call it XLLM for Extreme LLM, very fast because of that. There's many features that I've added over time, and I've seen many other, we call it competitors if you want to, but openAI, Meta with LLama and stuff like that, Databricks, they started to kind of copy my idea. I'm not saying that they read my documents and then they just copied. Some, yes, and probably they invented on their own as well. But I was happy to see that they do what I do, like with 3 months delay or something like that, and kind of validate what I'm doing. Was very happy with that. Like, for instance, you might have heard the concept of multi-token. I invented the word like 3 months before I saw it used by Meta. Mixture of experts. I didn't invent that word, but the concept of a multi-LLM with a number of sub-LLM, essentially, and each of them specialized, like an expert on some topic, is turned out to be called multi-expert LLM by some of the companies, just to give you an example.
It really seems like there are sort of two motivations then for customizing LLMs or creating your own custom LLM. So the first one you mentioned was in terms of changing the style of the output to suit different audiences. So, for example, you said that you wanted more technical information, and a lot of like the sort of foundational LLMs, they will talk to the common user. So having that sort of technical language seems like quite an important use case. And secondly, getting that domain-specific knowledge. So in this case, you said you wanted information about the stats and maths.
Yeah, by technical, it does not necessarily mean technical. For instance, the corporate clients, what they are interested in is to deal with the corpus. A company like InBev, they have some information that employees are accessing regularly. So they have a lot of information regarding HR, marketing, finance, sales, tech, and stuff like that. They're interested in a sub LLM for each of them. And we can assume that the user who is asking for something specific, trying to retrieve document tables, images, and stuff like that, is it's not really a beginner. So it's not the the common man. The user typically in this case so far would be an employee of InBev. So he knows what he's looking for and expect to get answers that are not basic, that are going to be really valuable to him or her. The other issue was the cost as well. So because those like GPT-4, stuff like that are based on deep neural networks, they use a lot of GP, billions of tokens. And I believe they've not been designed to serve needs like that, like for corporate clients. They might have been designed to replace Google search or something like that. So they're also charged by the token, and they have a large number of tokens. There's an ecosystem around this that everybody's happy if you charge by the tokens. Tons of weights. Company like NVIDIA are also making lots of money thanks to that. And I might be one of the few that went into an opposite direction and want to make the things as inexpensive as possible while without jeopardizing the quality, actually even delivering better quality on specific topics. One feature in the XLLM architecture is that in addition to the prompt, you can have another box where the user can specify which sub-LLM he wants to query. And by sub-LLM, I mean top categories. Are you looking for information about HR, or are you looking for stuff about legal? And sometimes some stuff that the user is looking in one sub-LLM is going to be found in another sub-LLM. Like, for instance, I'm talking about the statistics and probability sub-LLM, which is a mathematical flavor because Wolfram is a mathematical website. But if you look for something like gradient descent in the statistics and probability sub-LLM, you're going to find little, maybe nothing. But there's plenty of stuff like that on the calculus sub-LLM. So that's where the LLM router is here to tell the user, even explicitly or not, that he needs to get that stuff from a different sub-LLM. And one of the things that the corporate client was also interested in, so you can have different types of LLM based on the content, but you can have also different types of LLM not based on the content, but the content might be identical, but based on the type of information you want to provide to the user. Is it someone who is looking for very highly technical stuff or more like definitions? So the flavor, to put it this way, the flavor of the LLM could result in different LLM serving different goals. You might have heard words like actions in that context is being used by some of the folks. One thing that I would like also to talk about quickly at some point, I don't know if we'll have the time, but I want to mention it here. So one of the key features of XLLM is that it's based on taxonomies, knowledge graph from the very beginning. So it's kind of the bottom layer. While these days you hear knowledge graphs, so it's becoming popular, everybody's starting to use, but they are putting it like on a top layer. They're trying to build a knowledge graph. In this case, the taxonomy, the knowledge graph could be related concept. It's embedded into the website or the corpus itself. For corporate corpus, you have a breadcrumb. You know where you are in the tree or hierarchy of the categories. You also have related concept. On the web pages, you look for something, it's going to point to some other links. So you have all this taxonomy and knowledge graph actually there on the website. You can just simply crawl it. So you may say it's kind of cheating. In this case, I've not built a knowledge graph from scratch. You can do it. I don't have the time to go into the details like that. You can augment the taxonomy. The taxonomy can be poor. Some part of the taxonomy can be poor. You can improve that. But for instance, in the case of Wolfram, you had a pretty decent taxonomy that you can really crawl. And one of the reasons other folks are not doing it is that if you use tools like Python library, Beautiful Soup, for instance, it may not be obvious how you're going to kind of retrieve those taxonomy elements, but they're there. It requires a little bit of 1 or 2 hours of work to find how am I going to detect these pieces of information and rebuild the taxonomy, but it can be done. And what is interesting is that all the major corpuses that I've looked at, corporate corpus, Wolfram, Wikipedia, they do have a strong structure. So you always hear this is unstructured text. Actually, it's pretty well structured, and you can recover that structure. In the case of Wikipedia, so it's very similar in all these corpuses. In the case of Wikipedia, for instance, machine learning would be a sub-LLM. The taxonomy is good. When there are some things that you can ignore. In a statistics, to the contrary, so you can browse Wikipedia. What I'm saying here, you can browse Wikipedia by looking at the kind of a top page that tells you what are the categories, subcategories, and stuff like that. And then from these top pages, as a user, as a human being, you can go down. And so that's what I'm talking by the taxonomy that you can recover from the website. And on Wikipedia, the statistics, statistical science, taxonomy is pretty cool. It's better in Wolfram Alpha. There are benefits and on Wikipedia in the sense that even though it is a poor taxonomy for statistical sciences, the content is pretty good. It's more comprehensive than on Wolfram, but even for Wolfram is a better taxonomy. That's where I probably don't have the time to go into the details, but in the end, you're going to end up not only with content augmentation, but also taxonomy augmentation or knowledge graph augmentation. If by any chance you're working with a corpus that don't have these features, you can use some external taxonomy or
It sounds like there were two really interesting architectural decisions you made there in terms of creating your own LLM. So the first one was around using this mixture of experts approach where you've got a sort of two-stage approach to the LLM. So you've got the first layer just chooses which of the experts are going to give good results. Then you've got these experts which are smaller LLMs, which are going to provide the actual response. And then the second one was the use of knowledge graphs. So I'd love to get into both of these in maybe a bit more detail, but we'll cover the mixture of experts first. So this is the approach that you mentioned has been championed by Mistral. And I've heard rumors that GPT-4 from OpenAI is also based on a mixture of experts approach. Can you talk me through how you decide what each of the individual experts should be?
Yeah. So for corporate corpus, we're working on that right now. But the idea would be that you have pretty well separated component. I mean, they overlap, of course, but like HR, legal, marketing, sales, all the things that a corporate that you find in corporations. And obviously, you can have also subcomponents. We're not there yet, but you can imagine an LLM made of multiple sub-LLMs, and the sub-LLMs have sub-LLMs, a tree like that. But I don't think we'll get to that point. It's too much granularity, in my opinion. The risk is that those sub-LLMs, if they are too small, it brings so much. This kind of an optimal size. Too big, you get hallucinations potentially. You have billions of weights or tokens. And what I found myself, because at some point I created multi-tokens, which are tokens instead of data science, the word data science is just one token. And then what I call contextual token, like data science, the two tokens may not be adjacent. They could be found in the same paragraph, but not adjacent. But when you start working with these multi-token or contextual tokens, you can have an explosion in the number of tokens, even in my much smaller system. What I found in the end is that very few, like typically I'm going to be having maybe like 5,000 tokens for a sub LLM. If I don't pay attention with these multi-tokens, it can grow to 10 million, something like that. And what I found is that most of them are never fetched from the backend tables when you serve a user query. So they kind of know it's useless. And even worse than that, in case they are actually fetched, most of it is noise or garbage. It can corrupt a little bit the answer that you're going to provide to the user. So having a big token or weight tables can cause problems. And having tables that are too small are also going to cause problems. There's some kind of an optimum somewhere.
I find that approach really interesting in that it mirrors the way you would ask your colleagues for help. So if you think, okay, I've got a problem, I want to ask one of my colleagues what the answer is, and you think, well, who in my organization is going to be the best person to answer it? And then you ask that person. So in a way, this sort of mixture of experts approach is sort of is mimicking that. So you decide which LLM should I, or which LLM expert should I call, and then that expert gives you the answer. And it sounds like in a corporate situation, each of these smaller expert LLMs is going to represent maybe like the head of department for that particular team. So you said you had like a marketing expert, a sales expert, an HR expert, and so forth. Okay. So the second idea you mentioned was around the use of knowledge graphs. So my understanding of these is that it's very helpful for letting the AI understand relationships between different objects. Can you talk me through how that knowledge graph interacts with the neural network part of the LLM? How do they fit together?
Knowledge graph, there are two things about them. First, they are made of high quality words, high level keywords that may be made of 2 or 3 tokens, but it's not like written text, or it's high quality. Sometimes it's actually it's been created by humans, like all these categories, subcategories on the Wolfram Alpha. They've been made by there might be like 5,000 of them, probably more than 5,000 categories, subcategories, and Wolfram. And then related concept, which is the knowledge graph, they've been created by human beings. So they're supposed to be on high quality, and they consist of word tokens that are very clean, of superior quality compared to the words that you're going to find in text, in the summary words. So if you use them also in your embeddings, and you put a higher weight on these knowledge graph words, you're going to, in the end, get better results in the output that you show. You're able to also provide to the user in the answer related concept. So it's much more easy. So that was one of the things, is so to use them for in the embeddings, and you may put the higher weights on the tokens that are coming from the categories or knowledge graph, as opposed to the one that are coming from straight text. Then the other thing is, you have all these relationships that is and provide. So some users are going to want references or related concepts, and that's where these knowledge graphs can be particularly useful. I don't know if I've fully answered your question. I have a feeling I'm missing something in your question.
So I think just to make sure that I've understood this correctly, the idea is that because the knowledge graph shows relationships between different concepts, it's then going to link to different related bits of text. So if you ask a question about one thing, it can, if there's some text that is in some part of the knowledge graph, then it's also going to return ideas that are in adjacent nodes in the graph. Is that about right?
It is the ability to jump from node to subnodes to sub-subnodes, up or down, higher level, lower level, parallel. The risk is you can return a tremendous amount of information to the user, even for the answers are extremely concise, like bullet items. You can have, if you are asking to go 2 level deeper, 2 level above, and stuff like that, you can end up with massive output return to the user. It could be of some valuable. So in my case, actually, I allow for that, and you can save the results as text file because the output can be pretty big. But the challenge is to find some kind of optimum, maybe to stick to the closest possible items in the knowledge graph, and everything here comes with a number, not necessarily an integer number, a score, which a real number, a positive number typically, or maybe normalized between 0 and 1, and that score is going to tell you the relevancy between some original piece in your prompt. So your prompt might have multiple pieces, there may be multiple embeddings that you can derive from your prompt, which by itself also, if you have stuff unrelated concept, you're asking for 2 different concepts in your queries. It'd be better to separate them, but then you need to be careful about the amount of information you're going to return to the user because of the knowledge graph. Knowledge graph essentially is global context. You from one query, you can return the whole thing. It's like human beings. You are connected to any other human being on Earth with a 6-link connection. You probably have heard about the story that we all six links apart from anybody else on Earth. So it's an interesting problem.
Okay, that's interesting because I think one of the most common complaints with these large language models is you give them a simple question and they just return paragraphs and paragraphs of text, and you think, well, you just answered that in the first sentence. It wasn't. I didn't ask for all that. So I can certainly see how making use of these knowledge graphs, you could end up with way too much text, and then that's going to give those really verbose responses.
Yeah, and also with knowledge graph, one of the issues when that can cause to return tons of output is if you focus on individual tokens, you look at all the information attached to data science. You return everything that's related to data, you return everything that's related to science. But you should focus on what's related to data science. Here I'm providing a simple example, but you get the idea. The problem with sub-LLMs that are pretty small, for some keywords, you are going to have information from one individual token, but not necessarily for the joint token. That's one of the reasons for the race for the biggest possible LLMs with a massive amount of input sources and weights is to be able to, in your database, to have word consists of 3 or 4 tokens with enough information about them to return useful information. Another way to do that is to have a specialized LLM, like an expert LLM on some topic, and then have a bunch of them. Like I like to say, the statistics and probabilities of LLM. You have 15, something like 15 of them. You cover everything mathematics. And here, the focus is knowledge management. I'm not trying to produce code or other stuff like that. It's more like, it's actually very useful as a search. And then with 2,000 of them, you essentially cover the entire.
Okay, wow. So actually, you're mentioning that you can consider the phrase data science as a single token. Suddenly something just clicked in my brain, because the recent announcements from Meta about Llama 3 and from OpenAI about GPT-4o, they both mentioned the idea that they're doing embeddings more efficiently, where the number of words you put in corresponds to fewer tokens than before. And I hadn't really understood why that was the case. But it sounds like if you've got data science being one token rather than two, then that becomes more efficient in the model. And then it's going to be cheaper for people to use as well, because I think, particularly with OpenAI, they charge like per token of input, per token of output. So you're going to get more relevant results because it's considering the phrase rather than two words separately, and it's going to be a bit cheaper for you. So that sort of all makes sense now. All right, so maybe we'll move on from some of the technical talk to about how and why you might want to get started with the custom LLM. So what sort of organizations are you seeing make use of custom LLMs?
Yeah, so the one that they've been most interested in what I'm doing, they're going to be clients, as opposed to companies that design AI and Gen AI. So I mentioned InBev is one of them. Morgan Stanley is another one that showed interest, and it was actually the same thing. They were interested in managing their corpus and returning meaningful users much better than what they already have in place, because they already have something in place. They adjust. So two things now that I'm thinking about that. You mentioned embeddings, efficient embeddings. So multi-tokens is part of it. Being careful to not make the number of tokens explode by using multi-tokens. That's a risk. And one of the features in XLLM is variable length embeddings. So I did not invent the concept. Not many people talk about that. It might not be that friendly if you use vector databases, which assume a fixed length for your embedding. But when you use variable length embedding, they can be much shorter if on average, they're going to be shorter, so it's going to be faster, as opposed to, because those fixed length embedding in big system, they might 8,000 tokens. So yeah, in each embedding is something that's typical. Then another component, I've heard some people talking about this idea that's not that many yet, is the prompts. So to use the prompt is input to augmented data, to put it this way. So you have millions of queries. You can analyze them. And so they're going to be multiple interesting things coming from it. You're going to see what the user are looking for. This might help you refine your taxonomy, find stuff. Oh, this is a lot of users are looking for this stuff. This stuff is not in the corpus. So maybe we need to augment the corpus with external sources that answer. Maybe we need to create new pages on the corpus to answer these questions for the users. So that's another interesting component. And then the other component that some people are also talking about it, you might have heard the word, is caching mechanism. So you look at the prompts. What are the typical embeddings? What are the top 1,000 or top 5,000 embeddings that can be derived from the prompts? And you just put them in a caching. There's a caching mechanism. So in real time, when you deliver these results in real time to a lot of users, you create embeddings derived from the user prompt, and then you need to merge them and to find those that are close to those coming from the user prompts in the backend tables. That can take times, especially if these tables are immense. So caching mechanism can help as well. Variable length embedding can also increase speed. So the way I've been doing this with variable length embedding is nested hashes. So hash is a dictionary in Python. So it's a key value database, but the value is the hash itself. It can go 2 or 3 level downs. The key can be a hash itself. It's very efficient to handle sparse data. What I mean by sparse is if you have 1 million tokens or 1 billion tokens, and the association between one token and another token, for the immense majority, there's no association. You pick up one token at random, another token at random, there's no association. This is what I mean by sparse. And tokens that are really connected somehow and associated in this huge list of tokens represent a minority. Like, to put it in a different way, let's say you have 1 billion tokens. You want to create a table of associations between tokens. You'd say 1 billion by 1 billion would be, the dimension of the table. But in reality, there might be only 3 billions relationship that exists in the corpus. And so those nested hashes, it's an efficient way to deal with it. It's a format that's a little bit similar to JSON, but you can also use graph databases to represent that kind of structure.
Okay, a lot to go there. So let me see if we've got this. So it sounds like the most important use case then, or the most common use case you've seen for these custom LLMs is for corporations wanting to have some sort of Q&A for their own corporate knowledge system. It seems like managing what you know as an organization is incredibly tricky. And I like that you mentioned there's a sort of feedback there where if the AI gives poor results, then it's probably going to tell you haven't got documentation on whatever it is people want to know about.
Yeah, and with a type of documentation which could be people looking for definitions, people looking for case studies, for examples, for code. Not here that my XLM are not generating code, but are going to retrieve code that users are looking for. And then it's becoming quite odd these days, search in general, especially search for advanced search or search for experts, essentially replacing Google. You might have heard that OpenAI, I don't know where they are right now, but they seem to be interested in fighting, going to war against Google for search. And myself, if you look, so sample of my output, and I can share later. It's everywhere anyway. It's easy to find. But the first section that I return to the user, not for the corporate client, but in the kind of research section, is URLs. And the title is organic URLs. So what it means, have in mind that this can be revenue could come from sponsored URLs. And I actually do have a client who's very interested in this idea. So that's interesting.
Absolutely. There would be an interesting economic model where you have paid or promoted search links within the AI response. I'm not sure people want that, but I suppose the economics of generative AI might make
there would be different layers. There would be one with, like pretty much everybody is doing tech these days. You have this free version that comes with advertising, and you might have a paid version come with a SDK or You get full access to the backend tables, the embedding and stuff like that. It gets updated more frequently. So if you pay, just the way it works right now. But I wouldn't charge by the token. That I want to avoid that.
And just, I suppose thinking about it more, like if I was like shopping for new fancy shirts, then if I'm asking the AI what to buy, then having some links to the actual products would also be helpful rather than it just naming some brands and then.
Yeah, I'm not going into that direction. I will leave that kind of stuff to Google and the other folks. It would be more if you're looking for more like scientific or topics in biology, medicine, computer science. I'm not going to, for instance, focus. That's not the plan on looking for the best restaurant around your place or stuff like that. So it's more like knowledge, essentially, as opposed to anything else.
Now, actually, well, we're talking about the economics of this. So a lot of the technical innovations that you mentioned, so things like the variable length encoding, caching, more efficient use of sort of sparse data, these all sort of point to the fact that generative AI is still quite an expensive technology, like both for training models yourself and also for running these large language models, because it's quite computationally expensive. So can you just maybe give me an overview of where these big costs come in? Like, what are the most expensive parts of working with generative AI?
Well, because they are using like a billion weights. So what a weight is could be a number that's going to be attached to a token. So they get updated. So there are a lot of updates. These updates, typically what it is you have a deep neural network. So a weight, when you change a weight, it means you may activate a neuron in your neural network. So that's what eats a lot of the time in these implementations. That's what requires a lot of GPU. That's why there's a lot of cost associated with it, the main cost then. Now, if you have tons of users in real time and you need to deliver answers very fast, there's another cost in, because you need to efficient mechanism. That's why you probably heard words like approximate nearest neighbor search, which is one of the techniques they use in a vector database to kind of match an embedding coming from a user prompt to an embedding in backend tables. But when you have that on a very large scale, you have these costs. Testing, evaluating is also expensive, because when you change these neural networks, retraining is going to take a lot of time, and in kind of an implementation that if you don't have those costs. I like to joke, I even mentioned that with my client. You can download the whole internet, I would say 99% of what's going to be useful in terms of knowledge, on your laptop, and not even the most expensive, or my laptop is, I don't know, maybe 6 years old. I could do that on my laptop. What's going to take time in this case is going to be the crawling. You can have distributed, you can make it in parallel, but still, if you crawl the whole internet is a little bit easier. When I crawled the Wolfram corpus, I think it was like 15,000 URLs. It's kind of small. It can go real fast to check. It's really fast to extract the whole thing, but you get blocked. If you realize someone is hitting the whole website. So while if instead of you have plenty of websites, you're not going to hit massively one website at a time. It's get distributed. So you avoid these problems. And I know openAI, they don't even do any crawling. They use OpenCrawl or something like that. So you can also use those external tools. But it brings also under the concept: should someone or me or anybody else be allowed to crawl those websites? And I mean, sure, it's not illegal, but is it ethical? Is it fair? Should I pay Wolfram? Well, these are questions that important questions, the ethics behind that, and what you're retrieving as well. Me, I'm essentially retrieving knowledge, so I have fewer problems than maybe companies like openAI. If you retrieve personal information and stuff like that, then it's another challenge.
Yeah, absolutely. Certainly just trying to scrape the whole internet or scraping like everything from some particular website. You've got to be very careful about the legalities. And I'm sure most websites have a notice about like what's permissible buried within there. Like there'll be a robots.txt file or something to tell you what you're allowed to do. But yeah, that's very interesting. The idea that actually, if it's sort of ethical and the website owners are okay, you can just get a load of data and on something you're interested in, download all that to your laptop, and then go and create an AI, create your own bot from it.
Yeah, the case of Wolfram was interesting because initially they blocked me. Obviously, I found some workarounds, but eventually they unblocked me, and I believe they must be very happy because it got a lot of publicity. A lot of people have seen these results coming with Wolfram Alpha with URLs from. I'm sure. So that's also one big thing. OpenAI is not going to tell you where that content comes from. Me here say this is the URL on Wolfram Alpha. So I believe that in the end they were very happy with that. It's especially me mentioning that's one of the best websites for everything mathematics if you want to start with. So
yeah, that level of transparency is incredibly important. It has been kind of lacking from a lot of the big players in the generative AI movement. Certainly, particularly OpenAI isn't very forthcoming about what sort of data they use. And I agree with you. The Bull from site for their glossary of mathematics is absolutely amazing. All right, so just going back to the costs of things, it seems like a lot of organizations, if they want a custom LLM, they've got this choice between do they build something themselves? Do they maybe buy something off the shelf and fine tune it? Do they get someone else to try and create the LLM for them? Can you talk me through how organizations should think about this sort of build versus buy decision?
if you design your own LLMs, it's not necessarily perfect. So there are also some drawbacks that that come with it. First, it's not been as thoroughly tested as stuff like OpenAI. You might have, if you have an expert who's developing the LLM for your company. What if that guy disappears or that guy leaves and it's not properly documented or stuff like that? So you're facing issues like that. Obviously, the benefit is going to be should be much less costly. You have full control over what's being done, and there's increased security. But you have a local implementation for these days. Many of these big LLM companies are also offering local implementations. So it's not black and white that one is better than the other or stuff like that. So there are drawbacks in both approaches.
And do you have a sense of who you need to create one of these things? Like, is it going to be a single AI engineer? Is it going to be a whole team of people? Like, what do you need to get started?
Another issue actually with this specialized LLM, especially if you want high quality, I use a lot of customized tables, so stop words. If I use autocorrect libraries from Python and specialized LLM, they're causing problems. The autocorrect stuff that should not be autocorrected. So you do not autocorrect stuff, tables. And building that, I don't think it can be fully automated. It's going to be requiring some human interaction by, you look at the results you get, and then you find out which stop words you need to add into your table. So there's human beings, there's a cost there. So I actually made a computation one day that for the whole internet, if I was to cover the whole internet, you make a big scalable, company, I would need like 20 full-time people working just on optimizing, looking at the stopwatch, doing that kind of stuff. So a team of 20 people focusing on that, that would be the biggest, most expensive component, more so than the engineers, IT. And then, because someone asked me the question, do you need a lot of human beings to fine-tune your system? By the way, I also use a lot of human beings. I even myself receive offered to work for them, testing prompts and stuff like that. But the cost company like OpenAI is mostly is going to be engineers, while in the end, with my 20 employees paid full time, not going to be cheap employees, you can be experts. It's still less than the number of people a company like OpenAI must have. I don't know how many employees they have. I would assume hundreds. I may be wrong.
Yeah, I think there might be thousands of people at this point in OpenAI. But so that's interesting that the biggest cost then is, so I believe this is like the reinforcement learning from human feedback step. So this is people who are checking the results of the output and then marking it as good or bad.
Especially if you want to do it fast and cover the whole internet. For instance, the case for a corporate client, I'm going to be to myself. I'm not going to spend many hours looking in, but it's a very small part of the whole knowledge, doing those kind of tests myself. I don't have those expensive GPU and training costs. That because besides the engineers, of course, there's the computer time cost that OpenAI and Mistral and those companies are facing.
So that's interesting. So let's sort of recap like which skills you need then. So it sounds like you're going to have some people who are involved in a lot of like doing the data processing. You have data engineers, people who are experts in data management up front, and then you need some AI engineers to actually build a model, and then you need some experts to be able to test the model output. Is there anyone else that needs to be involved if you're wanting to create a custom LLM?
Obviously, you need all the traditional people that you would find in a company. In my case, I'm pretty lucky because it's new. People are noticing what I'm doing, so I don't have a sales team. People are knocking at my door. In company like InBev, they came to me. Morgan Stanley, they came to me. I'm also, self-founded, but very well self-founded. I sold my previous company. So I don't have this pressure to try to make money ASAP that I'm going to run out of money. So I don't have that aspect. So I was talking sales.
It sounds like you need all that kind of standard support stuff. So your project managers and your
I do have an engineer actually, which is working with me, is designing web APIs for my product. The guy was is in India actually, was a Oracle principal staff or something like that in India. But I think you need more like ML dev engineers as opposed to research scientists. Well, I do a lot of research myself, but I would not need to hire another guy doing what I'm already doing. You need a guy like that, obviously. And if possible, a guy like that, who, for instance, in my example, I'm not just a pure academic research guy, a guy who knows how to code, a guy who's going to be very close to the engineers and like a co-founder, which, I am in this case. And I think you also interested maybe to know the Python, what the skills. So there's what I call smart crawling. So it's not just what you typically would learn from a simple boot camp or something like that to extract the taxonomy, to retrieve the knowledge graph, and to do it efficiently. So stuff like simply using beautiful soap in Python is not enough. So you're going to need some training, possibly in Python, on web crawling. It's certainly very good to be familiarized with all the NLP libraries, so a course on that topic. I faced many issues with those libraries, and some of the stuff that I rewrote from scratch better serves my needs in this context than some of these Python libraries. Yet you still need to know what they are doing, what drawbacks come with these libraries, and in some cases, these drawbacks are easy to fix, like do not stop word or do not autocorrect to create stuff like that. And at the same time, you still leverage those libraries.
Okay, so just on that note, so these Python natural language processing libraries, I presume you're talking about things like NLTK and Spacey and things like that. So it's interesting that these are still very relevant in the age of generative AI, because I think some people sort of thought, well, okay, now we got these big large language models. I don't need those older NLP tools. So that's interesting that they are still useful in the context of generative AI.
Yeah, any better tools, any new tools that come that are going to replace these libraries are definitely worth investigating. So it certainly would be nice to find out what those the new libraries and more specialized libraries that come with it. So another example is I did use the LLM for clustering predictions. Everybody is doing that as well. But in any ways, I use sklearn Python libraries to do some clustering based on text. So there's a dissimilarity matrix there, but I use it. So like I mentioned, I really leverage sparsity. So you're really dealing with very sparse data. So sklearn, unless I'm missing something, is asking me to build a distance matrix. So if I have a million token, it's a million by 1 million token, and you do the clustering on that matrix. It's very simple to create that distance matrix out of your similarity matrix based on hash tables. But the problem, you run out of memory, stuff like maybe I'm missing something with sklearn. Maybe there are some other libraries, but the simple libraries like that are not going to be enough. In my case, I do it some very efficient way to do clustering with connected components, graph-related technology that's leverage the sparsity of the system. So what I'm saying here as a summary, if you just use the standard libraries, you're going to run into problems. You need to go beyond that. And at the same time, you don't want to reinvent the wheel. It's a risk also so you need to be knowledgeable of what's out there, what you can use. You can even use openAI to create some code, asking some code to solve some problems. I did, and in some instances, I got some great stuff, actually.
So yeah, it seems like an understanding of sparse data is going to be incredibly important for this, and then understanding knowledge graphs as well. So there's quite a lot to learn. Yeah. Okay, wonderful. All right. So before we wrap up, what are you most excited about in the world of generative AI right now?
Well, we're turning points where there's a lot of old stuff like Google search that are being revisited and can be done much more efficiently. It's like I was just writing this very recently. Search is going to be powered by RAG LLMs. It's the end of PageRank.
The end of PageRank, that's a bold statement. I think there can be a lot of people at Google are a little bit frightened about that.
Yeah, then I've been working on some of the projects as well, like Nogans. There's plenty of low hanging fruits. People are complaining about how bad many of these tools are, the poor results. I found this is exciting. There's so much thing to improve. It's going to be improved. There's a lot of work that to do. There's some jobs that can be created, and I create my own jobs. But I mean, people are talking about this technology is going to replace everyone. But for now, my opinion is that there's plenty of low hanging fruits. There's a lot of demand. I mean, people are talking about billions of dollars associated to LLMs. The market costs are going down. The system are being improved. I mean, it's just like the first cars, they were driving, 40 miles an hour. you need to know how the engine works, the broken road with potholes and stuff like that. Now you don't drive a car. It's I believe it's going eventually in the same direction.
Wonderful. That's a very optimistic take, and I like that. The idea that, well, if there are problems now, then that just means that there's something to be solved. So there's interesting things to do.
Yeah, and especially when some people, and even sometimes myself in mathematics, I think everybody's been discovered already. We're in the end of it. There's no more thing to discover. But that's not true at all.
That's wonderful. I love that. So thank you so much for your time, Vincent.
Thank you so much, Richie. Very nice talking to you. Thanks for the invite.